Yo, what's up, my dude? The surf's looking pretty gnarly out there. I think I'm gonna grab my board. This is the perfect time to catch some sweet waves. Wanna come with? It's gonna be totally radical. Hi, friends. Another opportunity for me to make a joke at the expense of the word radical, and an opportunity to do a bad surfer impression. Might as well take it. Welcome to our 7th class of Unit 6, Using Properties of Radicals, Part 2. So, once again, you have a problem set to complete for me tonight, which means this video is optional. If you don't know the definition of that word, that means you don't have to watch it. You don't need to take notes. You also, if you want to watch, don't have to watch the whole thing. But this is a resource for you if you feel like you need a little bit more practice. Okay, our goal is to get any radical expression to simplest radical form. And there are 3 parts to our simplest radical form. First of all, I need to make sure that I am not leaving any perfect squares or perfect cubes under a square or cube root, respectively. I also know that I never want to leave a square or cube root in the denominator of a fraction, which means I need to rationalize my denominator. And last but not least, in each term, so between any plus or minus sign, I should see no more than one square or cube root symbol. With those 3 criteria in mind, let's do some practice. So, the square root of 48. Again, I'm not going to pause at any point, but I encourage you, give yourself a little bit of time, work out each of the answers in each set of problems before you check your work with me. So the square root of 48. I know that I have a square root, so I need to make sure that there are no perfect squares in the factors of 48. Well, 16 is a factor of 48, and it is a perfect square. So by the product property, I can rewrite 48 as 16 times 3. The square root of 16 I know is plus or minus 4. The square root of 3 I cannot simplify further. I will just leave it as root 3. Smush it up against that 4. Plus or minus 4 root 3 is my final answer. Same thing for the square root of 150. I need to look for any factors that are perfect squares. Well, this is a multiple of 25. Using my product property, I can rewrite the square root of 150 as the square root of 25 times the square root of 6. From here, I don't know how to simplify the square root of 6, but the square root of 25 is either positive or negative 5. Smush it back up against that root 6. Plus or minus 5 root 6 is my final answer. Now for the cubed root of x to the 10th. Again, we have some variables, but don't be frightened. They work exactly the same way. The idea is that I cannot leave any x to the thirds under my cubed root. So let me see how many x to the thirds I'm actually working with. Well, remember that x to the 10th, this could be from a property of exponents if I multiplied a bunch of x's together. I'm going to choose to break this down into as many x to the thirds as I can. X to the 10th. Well, I have x to the third. X to the third, again, that would give me x to the 6th. X to the third here would give me x to the 9th. And then to get me back to x to the 10th, well, I need to add one more copy of x back in. From here, let me split this up using my product property. This is the cubed root of x to the third times the cubed root of x to the third times the cubed root of x to the third times the cubed root of x. Well, once again, if I take the cubed root of a perfect cube, I am, of course, left with the thing. So the cubed root and the cube end up canceling each other out. So I'm just left here with x times x times x times the cubed root of x. And x times x times x I can more simply write as x to the third times the cubed root of x. Here, I am actually going to leave that invisible multiplication sign visible because I might have a hard time distinguishing between the 3 attached to the x and the index, right, of that radical. For the square root of 49, a to the 4th, b to the 3rd. Again, let me do some splitting up. When in doubt, I'm going to chunk it out. So I'm going to take a number chunk, an a chunk, and a b chunk. Again, I now need to make sure that there are no perfect squares. Well, the square root of 49, this is plus or minus 7, but I'm going to hold off on the plus or minus for now. For the square root of a to the 4th, here I know that a to the 4th I can rewrite as a squared times a squared. And then b to the third, I need to see if there are any b squareds in there. Well, I could rewrite b to the third as b squared times b. From here, breaking everything down, I now have 7 times the square root of a squared times the square root of a squared times the square root of b squared times the square root of b. Again here, a square root and a square, these guys are going to undo each other. I'm left just with the variable underneath. So this would become 7 times a times b. The square root of b cannot simplify further. All that's left for me to do is smush everything back together. Well, I have 7. A times a I can rewrite as a squared. I've got a b, and then my root b at the end. I'm dealing with square roots. I add in my plus or minus. There is my final answer. Very nice, and on we go. Let's do some quotient property. The square root of 8n squared over 25. So again, take some time, pause, try and work these two out, and then come back and check your work with me. Let's first of all split up our fraction. So I'm going to take the square root of the numerator and the square root of the denominator separately. From here, in the numerator, notice I can break this down further. This is 8 times n squared. So I'm going to write this as the square root of 8 times the square root of n squared by the product property. And the square root of 25, I of course know is 5. Technically, it's plus or minus 5, but I'm going to hold off on my plus or minus until the end. From here, the square root of 8, I can further break this down. Remember, 8 is 4 times 2, and 4 is a perfect square. So I'm going to write this as the square root of 4 times the square root of 2. Again, the square root of n squared is plus or minus n. From here, all of this is over 5. The square root of 4 I know is 2, so this is 2 times the square root of 2 times n, all over 5. Let me now just figure out the best order to put the things in the numerator in. Well, I'll add in my plus or minus because I took some square roots. By convention, we know that usually the number goes first, followed by the variable, and then at the end, any roots that we're left with. So plus or minus 2n root 2 over 5 is my final answer. Next up, the cubed root of 8x to the 4th over 27y to the 3rd. Once again, let me take my quotient property. I'm going to split this up into the cubed root of 8x to the 4th over the cube root of 27y cubed. Splitting down even further now using my product property, this is the cube root of 8 times the cube root of x to the 4th over the cube root of 27 times the cube root of y to the 3rd. Well, in the numerator, the cubed root of 8 is just 2. The cube root of x to the 4th, right? Let me rewrite x to the 4th. I want to see how many x to the 3rds I can fit. Well, I've got x to the 3rd times x. And then here, the cube root of 27, is equal to 3. While the cube root of y to the 3rd, we know here our cube root and our cube, they undo each other. We're just left with y. From here, I've got 2 times, let me split this up, the cube root of x to the 3rd times the cube root of x, all over 3 times y, which I can more simply write as 3y. Once again, the cubed root of x to the 3rd is just x, so I've now got 2 times x times the cube root of x, all over 3y. Smush that numerator back together, 2x cube root x all over 3y. Nice! Moving on, let's do some rationalizing. I've got the square root of 4 over 13. Let's start there. So by the quotient property, I can of course split this down into the square root of 4 over the square root of 13. From here, I can simplify the numerator. This would be 2 over the square root of 13. But again, I cannot leave a square root in the denominator. I'm going to choose a form of 1 that eliminates the square root. Well, let me choose to multiply by the square root of 13 over the square root of 13. From here, in the top, I now multiply across. 2 times the square root of 13 gives me 2 root 13. The square root of 13 times the square root of 13, well, that just gives me 13. I got rid of some square roots. Add in my plus or minus. There's my final answer. 2 root 13 over 13 plus or minus. The square root of 5/3. Once again, splitting this upwards, I've got the square root of 5 over the square root of 3. Again, I cannot leave that square root of 3 in the denominator, so let me multiply by the square root of 3 over the square root of 3. I know in the denominator that any square root times itself gives me the radicand, so this is just 3. The square root of 5 times the square root of 3. I cannot simplify either of those further. I will rewrite this as the square root of 5 times 3, which is 15. Add in a plus or minus because I got rid of my square root in the denominator. My final answer is plus or minus root 15 over 3. And last but not least, the square root of 63 over 2. Once again, splitting this up, this is the square root of 63 over the square root of 2. The square root of 63, I need to look for factors of 63 that are perfect squares. Well, that's 9 times 7. So I can rewrite the square root of 63 as the square root of 9 over the square, or times the square root of 7 all over the square root of 2. The square root of 9 is, of course, 3. So this is 3 root 7 over root 2. Well, I cannot leave that root 2 in the denominator. Let me multiply by root 2 over root 2 and rationalize. In the denominator, the square root of 2 times the square root of 2 is just going to give me 2. And then I've got 3 root 7 times root 2. Well, I can't break down the root 7 or the root 2 any further, so I'm going to smush them together. 7 times 2 gives me 14. So plus or minus 3 root 14 over 2 is my final answer. Moving on. Let's do some multiplication and division. So I've got the cubed root of 25 times the cube root of 10. When in doubt, let's break it down. So 25, I'm going to break this down as much as I possibly can. 10, I'm going to break this down as much as I possibly can. Well, the cube root of 25, this is the cube root of 5 times the cube root of 5. And I'm multiplying that by the cube root of 10. I know I wrote it as 2 times 5, but let me write the 5 first. So this is the cube root of 5 times the cube root of 2. Well, we know if I take 3 copies of a cube root and multiply it together, one of them is the thing that multiplies by itself 3 times to get 5. So if I multiply it by itself 3 times, as I've just done, I should get 5. So now this is 5 times the cubed root of 2. The square root of 60 over the square root of 35. Again, when in doubt, let's break it down. So the square root of 60, I know, is the square root of 5 times the square root of 12. And the square root of 35, I know, well, 35 is 5 times 7. So this is the square root of 5 times the square root of 7. Notice here that I can now cancel out the common factor of the square root of 5 in the numerator and the denominator. I'm now left with the square root of 12 over the square root of 7. Well, the square root of 12, I can factor this guy into something that's a perfect square. 12 is 4 times 3. So I'm going to break down the square root of 12 as the square root of 4 times the square root of 3 all over the square root of 7. Well, the square root of 4 I know is 2 times the square root of 3 all over the square root of 7. Again, I can't leave that root 7 in the denominator. Let's rationalize by multiplying by the square root of 7 over the square root of 7. In the denominator, root 7 times root 7 is 7. And now I've got 2 times root 3 times root 7. I can't break down the root 3 or the root 7. Let me smush them together under a radical. This will become plus or minus 2 root 21 over 7. Same thing here for root 21 times root 12 over root 14. When in doubt, let's break it down. Now, I know that 21 is 3 times 7. I know that 12 is 3 times 4. And I know that 14 is 2 times 7. So I'm going to even take that 4 and break it down further, right? 4 is 2 times 2. So I can now take this guy and rewrite it. The square root of 21 is the square root of 3 times the square root of 7. The square root of 12 is the square root of 3 times the square root of 2 times the square root of 2. And the square root of 14 is the square root of 2 times the square root of 7. From here, notice, I can cancel out a square root of 2 from the top and the bottom and a square root of 7 from the top and the bottom. So there's nothing left in my denominator. All that's left on top is the square root of 3 times the square root of 3 times the square root of 2. Well, if I take a square root and multiply it by itself, I know I get its radicand, so this would be 3 root 2. I got rid of some square roots. Let's add in a plus or minus. Fantastic. From here, let's do a couple more. Let's do some like terms. I've got the square root of 500 minus the square root of 20. On the surface, doesn't look like they're combinable, but if I make some different choices, then I might be able to combine them. Well, notice here, for 500, I could identify that this is 100 times 5, and the square root of 20 is 4 times 5. 100 and 4 are both perfect squares. So the square root of 500 I can rewrite as the square root of 100 times the square root of 5 minus the square root of 20, which is the square root of 4 times the square root of 5. Well, the square root of 100 I know is 10 root 5 minus the square root of 4 is 2 root 5. Again, technically these are plus or minus, but as we saw in class together last time, usually when we're dealing with multiple terms, we're going to ignore our plus or minuses because then it would just get way too wonky. So we're going to leave this as just normal 10 root 5 minus normal 2 root 5. Well, I've got 10 root 5s. I take away 2 root 5s. How many root 5s am I left with? Well, that leaves me with 8 root 5s. Good. The cube root of 16 plus the cube root of 48 minus the cube root of 54. So here, 16, I'm going to look for common, or not common factors, but perfect cubes in its factors. Well, 16 is 8 times 2, and 8 is a perfect cube. In 48, I know that it also contains a perfect cube of 8 times 6. And then 54, I know that this guy is 27 times 2. 27 is a perfect cube. From here, I can now break each of these down. The cube root of 16 is the cube root of 8 times the cube root of 2, plus the cube root of 48, which is the cube root of 8 times the cube root of 6, minus the cube root of 54, which is the cube root of 27 times the cube root of 2. Well, the cube root of 8 I know is 2, so this is 2 times the cube root of 2, plus, again, another cube root of 8, so that's 2 times the cubed root of 6, minus the cube root of 27 is 3 times the cubed root of 2. Now I'm going to look for any like terms I can combine. Well, I see a cube root of 2 over here, a cube root of 2 over here. I've got 2 of them, and I take 3 of them away. That leaves me with negative invisible 1 cube root of 2 plus 2 times the cubed root of 6. Last but not least, the square root of 63. Well, I'm going to take this guy. This is 9 times 7. 9 is a perfect square. The square root of 40 is 4 times 10. 4 is a perfect square. The square root of 175. 175 is 25 times 7. 25 is a perfect square. And the square root of 90, well, that's 9 times 10. And 9 is a perfect square. From here, breaking everything down, the square root of 63 is the square root of 9 times the square root of 7, minus the square root of 40, which is the square root of 4 times the square root of 10, minus the square root of 175, which is root 25 times root 7, plus the square root of 90, which is root 9 times root 10. From here, root 9 times root 7, well, the square root of 9 is 3, so 3 root 7, minus the square root of 4 is 2, so I've got 2 root 10, minus the square root of 25 is 5, so I've got 5 root 7, plus the square root of 9 times 10, well, the square root of 9 is 3. From here, I'm going to look for any like terms. Well, I've got 3 root 7 minus 5 root 7. Well, 3 of them, I take 5 of them away. That leaves me with negative 2 root 7s left. And then I've got negative 2 root 10s. I add 3 root 10s. If I started with negative 2 and I add 3, that leaves me with 1 root 10. Very nice. Last but not least, let's do some distributive property. So I've got the square root of 2 times the quantity, the square root of 6, plus the square root of 8. My best move here is to distribute. So I'm going to take the square root of 2 times the square root of 6, plus the square root of 2 times the square root of 8. When in doubt, break it down, right? 6, I know, is 2 times 3, and 8, I know, is 2 times 4. So the square root of 2 times the square root of 6 is the same as the square root of 2 times the square root of 2 times the square root of 3, plus the square root of 2 times the square root of 8, which we can break down as root 2 times root 4. Well, here, I know that a square root times itself gives me the radicand. So the square root of 2 times the square root of 2 gives me 2. And then I've got that root 3 that I can smush up against it. And then here I have the square root of 2 times the square root of 2. Well, that, again, is going to give me 2. And then the square root of 4, I know, is 2. So this is really 2 times 2. So my final answer will be 2 root 3 plus 2 times 2, which is 4. For the square root of 20 plus the square root of 35 all over the square root of 5. Again, when in doubt, I'm going to break this down. We'll notice that 20 is 4 times 5, and 35 is 7 times 5. So I can rewrite this guy as the square root of 4 times the square root of 5 plus the square root of 7 times the square root of 5 all over the square root of 5. From here, notice, in each of the terms, I have a common factor of the square root of 5, so I can cancel this out from each of the parts of my fraction. That leaves me with the square root of 4 plus the square root of 7. The square root of 7 I cannot break down further, but the square root of 4 I know is 2. Again, it's technically plus or minus 2, but here for the sake of ease, we're doing addition and subtraction. Let's just leave it as normal 2. And last but not least, before we're free, I've got the square root of 14. I'm going to distribute it to the square root of 7 minus the square root of 2. Well, the square root of 14, I know this would be the square root of 14 times the square root of 7. Oh my God, the cops are coming for me. And then the square root of 14 times the square root of 2. They really didn't like my surfer impression. Now, the square root of 14. 14, I know, is 7 times 2. So let me take advantage of that fact. I can break down the square root of 14 into the square root of 7 times the square root of 2 times the square root of 7 in the first term, and the square root of 7 times the square root of 2 times the square root of 2 in the second term. Well, notice in the first term, now I have root 7 times root 7. Again, multiply a square root by itself, I get its radicand. So this is 7 root 2 minus, I've got the square root of 2 times the square root of 2. That's going to give me 2 root 7.